welcome everyone. We have Connor here. He's going to be doing his talk on Kubernetes containers. He can take it away.
If you want to try this one. All right, so as you can see, the IMAX projector is off, but we'll just make do. My name is Connor. I am a product manager. I work at a company called StackRox, and we do Kubernetes and container security. But I used to be an engineer, so I like to think I know some things still. Now, I sort of stumbled into Kubernetes maybe 2015 when it was nice and beta and fun, and the learning curve was still getting replication controllers, and that was all. Sort of introduced it to one company, and then about 4 years ago started building security tools. So now I've been kind of like seeing how Kubernetes goes out in the real world. Now, if you're coming to this talk, you probably heard something about Kubernetes. The slide that's supposed to be up is the CNCF landscape. Has anybody seen that before? So there's a nice tweet from Dan Kahn about how it's variously described as useful, overwhelming, and the hellscape. But has 6,000 GitHub stars or something. Now what it is a map of, here, the people in the front can see it, but it's a map of all the cloud native ecosystem. And the point is Kubernetes is just one little tiny box. And there's something like 100, 200 other things on top of it. So I'm glad that you're here. We have 6 hours. The doors are locked. We're going to go over each one. Yeah. Okay. So no, we're not doing that. What we're going to talk about, what? The slides are not online yet. I should have done that. Yeah, probably not a good time to try to do that, but I'm sorry. That would have been a great idea. Anyway, so what we're not going to do is go through the whole landscape. What we're not going to do is give a best practices talk. There's a lot of stuff that I've said, a lot of things other people have said about what you should and shouldn't do. That's not this. What I'm going to talk about, hopefully in about 20 minutes, minus our 5 at the start, is what it means. What does it mean for us, whether us means dev, ops, security, obviously a lot of security represented here, but what does it really mean for us? And because often we sort of debate, like, is this good, is this bad? And we don't think so much about all the nuance. And I got the nuance beaten into me in a thesis program, so I'm not going to try to inflict that on you either. But just want to go through kind of some of the details, go a little bit further into what it all means for us. So how we're going to do this is first we're going to go through the building blocks of Kubernetes, then take a sort of deeper look at different aspects of how it actually works in practice and what some of the implementations look like and the implications that has on folks. Ways to work together for how to actually improve security without losing all your friends, and then how to learn more. So that's where I'll go. And then for each of the things we're going to look at, we'll sort of go like, is this new or not? Because not everything is new. And then sort of, is it tilted more in dev and security for each of the building blocks and each of the features. I'm wondering if I should try to just get those slides online right now. Unfortunately, I don't do link sharing, but maybe I can do it. I'll time box it to 30 seconds here, and we'll see if we can get that done. Just copy it over. I was really hoping I could show you all these YAMLs so giant. I'm gonna share it with myself. And if this all shows up, this will be fun. And might be able to tweet it out before we move on. So I'm going to copy the entire one.
Oh, upload the Slack.
What?
If you upload it to the BSides Slack.
I am not in the BSides Slack. I don't know. I don't have time for Slack. I'm sorry. I have enough Slack at work. Ah, darn it. Okay, no, I'm not even signed in on my personal Google, so I'm just going to keep going. Sorry, folks. All right, so let's go into the building blocks. I'm glad I have this paper. I thought this was stupid, but turns out the IMAX theater is the analog theater today. So first thing, the hype. Hype isn't new. We're going to go through new, cool for dev, cool for sec. Kind of a shrug on coolness. I have some graphs of just like Google's trends of Kubernetes kind of up and to the right. OpenStack a little bit waning off. Other sort of cloud stuff. KubeCon attendees. KubeCon has grown to like, what, 12,000 people at North America, like 25,000 people overall. So lots of people talking about it. And did you know that every Chick-fil-A restaurant, at least as of like 3 years ago, is running a 3-node cluster in their restaurant? So something like a 6,000 node deployment federated across the United States. That's kind of interesting. Maybe the hype's, maybe there's something there. But let's talk about some of those neat things, regardless of the hype. So the first thing when you might think of Kubernetes is containers, right? Kubernetes.io, right on the homepage, will say Kubernetes is a production-grade container orchestration system. Now let's sort of look at all of those things. Now, if you have a container, if that's your cookie, your image is actually your cookie cutter. And there's going to be a giant Docker file, like 18,000 feet tall. But the cool thing, I mean, these are sort of new. I mean, we had image formats before, but I would argue that just the lightweight thing and the standardization of both the construction of the image and the distribution actually is enough to qualify as new. And also pretty cool for dev and pretty cool for security, because what you've got is actually a format that describes in detail all the things that are going to be in the file system when we start out. When this container starts, like what's exactly going to be there, all the way from slash up to whatever you've got. And then also some of the important runtime stuff. So like, what's the default user ID that you're going to run as? What kind of environment variables are you going to? How do you like to be stopped? What kind of signal would you like to be sent? What's your default command? It can be really easy to just sort of Docker run nginx or kubectl run nginx. And another really neat thing is, for the last couple years at least, we've had content addressable images. So we've got hashes of absolutely everything in there with a SHA-56 digest, and you can kind of know what's actually running out in the field, and compare it to something you pull from a registry. And if security is partly a config problem and partly a data join problem, really nice to be able to look at your configs with a SHA and use the SHA to join all your data later. So that's images to start. Then containers themselves. So I paid my royalties to the shipping container industry, stock photo industry, because that's the metaphor that's really useful for containers. It's not like a lockbox, not like a super duper tamper-proof thing, but just like a shipping container. You can throw it anywhere, throw it on a ship, throw it on a truck, throw it on a train. It gets where it goes. That's the metaphor that I like to use. Now, are containers new? Well, sort of. There are a lot of existing primitives. There's a Julie Evans Bork comic about what containers are. And in 15 lines of bash, you can actually build your own little container. You get a file system, give yourself a process namespace, give yourself a file system namespace, PID namespace, network namespace. That's kind of it. You sort of just put these all together. And that's pretty neat, because for dev now you've got this nice reproducible runtime environment. For security, maybe a little bit more mixed, because it's this new thing. And also because of the practices that we started using. So a little bit more mixed for security. Now, if I were talking about containers and security and I didn't mention escapes, I would be promptly yanked off the stage with a hook. The thing I want to say about container escapes is, they're not new. All the technology that we use to run different apps has different kinds of escapes and ways to get in and out. And also, we tend to think of container escapes being CVEs, but that's not the full picture either, because there are a lot of ways to get out of a container, especially if you take down most of the walls. If you saw Frenchie and Maya talk about that, there is one flag that sort of just takes out all of the containment that you might expect. So, not super new and not cool for really anybody, honestly. But as with any technology, it's a sort of a risk that we accept for some business value. Now, one interesting thing about using containers is that we do have the options to sort of build out different, package up different isolation techniques. So there are sandboxes like gvisor, VM-based solutions, where you can use that same container form factor, but sort of run it in a different way that has better or worse isolation. So that's escapes. And then orchestrators. So like I mentioned, Kubernetes is called an orchestrator. What is that? Well, once you start running your containers, they start needing other stuff. They need to talk to each other. They need to expose themselves to the outside world so that you can actually do something for a user. You need to end up getting a disk or a TLS key or something. And orchestrators sort of conduct. You all need to start playing music now, right? I'm conducting you. That's where you bring orchestration in. And then declarative immutable infrastructure, sort of best handled with a slide, but and maybe best handled with contrast. This is a practice that we use in Kubernetes, where that's not new to Kubernetes. I literally gave a workshop in a room called Terraform on Saturday, so believe me, I know this is not brand new. Way! Thank you. Now let's find where we got to. All right. Cool. And so declarative immutable, let's go back to middle school, grammar and think about this. What's the difference? This sort of declarative versus imperative. I just say what I'd like to say. I don't go do it. And then mutable versus immutable, like I don't go change what's running. So basically, like in Kubernetes, you end up just saying, I want this to be true. And you send a YAML, or more like 6 YAMLs, to the API server, and it kind of just does it for you, which is not a brand new concept, but pretty cool. And then it's neat for dev because it sort of reproduces. I'm gonna move this, and maybe that helps. It's also cool for security because you have so much information. More on that in a second. So let's move a little deeper. I mentioned, you've declarative immutable infrastructure. Sorry, this is. I hope nobody's epileptic. So this is actually, I think, something that's pretty new. It's having standard APIs for basically everything, down from the image, which is identified with that SHA we just talked about, to where in the system the workload's running, annotations people have given, all the other things that the orchestrator is doing for you that are really importantly, they're given to you in a standard form and they're discoverable. So that can be super helpful if you're trying to understand both what's running and with what kind of risk context, and also if you're trying to understand where you might need to go fix something. And I have a little quote, well I did, from the Kubernetes security assessment, just to prove to you that security people don't miss all the value for dev. It says Kubernetes does streamline difficult tasks relating to maintaining and operating cluster workloads. Okay. Now, one of the downsides, obviously, would be the new attack surface. So we've got the API, this all-powerful API, which has external exposure and internal. We've got new components like the kubelet and the Kubernetes dashboard, the Helm tiller, rest in peace, which are sort of definitionally new. Maybe cool for dev, kind of neutral, but not cool for security because we actually need to figure out what all these are and figure out what to do with them. And just them existing is different from you knowing how to configure them in a nice way too. A buddy of mine actually still hasn't deployed RBAC as of when I talked to him a couple months ago, and suffers prod outages sometimes because of mistaken automation, and that might affect our friendship. I reserve the right to use that against him. So one of the other things about having all the standard APIs is you've got granular Linux permissions. So capabilities, user ID, what kind of file system access you might have. Not new primitives, neutral for dev maybe, but because they're in this discoverable format, I think that's actually a pretty big net win for security. For networking, we actually get some very granular controls as well. So exactly which pods can speak to which pods, which containers get stuck to which containers. And this level of control is almost like a whole industry in RSA. Some companies have flamed out, buying all the ads at RSA just to talk about their segmentation. I'm not sure that devs necessarily care, but for security, this can be a really powerful thing. And having it all in a format that you can, iterate on, review, and deploy is pretty neat. Sorry, racing against the clock with this AV. Now, leaky abstractions and other sort of kube magic can be a problem. So again, kind of a new thing that we have to deal with. This is not the most magic thing, to be honest. It's just what I'm pointing at is this annotation here, where it's oh, if I just add this sort of free-form annotation, I end up really changing the security implications of exposing my service from being world readable to actually just only being on my VPC. So they're just these things where you might write a client that understands what a load balancer is, and then all of a sudden you've got an annotation that kind of comes in and messes with that. And broadly, we're actually smashing a bunch of different things together: cloud, Linux, containers, orchestration, everything together. And where the abstractions are, that's where the security fun can be. Now defaults, also I mentioned some of those. Now great things. So you run a container, it actually isn't exposed by default in Kubernetes. You got to actually go and opt into that. And the sort of the easy way is to be immutable, to assume that there's no storage, and to write an app that can be restarted. But there are a little more like chin scratching things as well. So like you'll end up running as root with like no network access control, a writable root file system, no seccomp, actually worse than Docker defaults for a variety of historical, not super interesting reasons. We don't have time for the audit log, but basically talking about how these have conflicting semantics. Some are opt-in, some are opt-out, and a lot of it's just based on backwards compatibility. So are those typical? Well, yeah, actually. The number of clusters I've walked into with network policies is probably on one hand, and I've seen many hands worth of clusters. Are people better at this than you think? Well, some are. There are people, like maybe people using K-Rail. I got you, man. But most people aren't. So sorry. Some examples would be exposed dashboards just hanging out there. Some of these are old, so maybe people are getting better. There's a Shopify bug bounty you should all read. My friend whose friendship is in jeopardy. And then most containers are running as root. So people started paying attention when runc had a CVE, but before that, 6 months, 9 months ago, like people mostly didn't do that. Now, one cool thing before we kind of zoom out again is enforcement workflows. So this is an example from a blog post one of my colleagues wrote. But basically, the cool thing here is you can give feedback right when the thing happens using built-in primitives like emission control. So you might have seen the K-Rail talk earlier. That's one option for emission control. You can build your own. You can buy a product like mine. But the cool thing is that you can give that feedback right away and keep bad stuff from coming out. Because the easiest bug or security remediation to fix is the one that you catch before it happens. Now let's wrap up. So let's just do an eye check. But really what we want to show you is the dev column and that set column. There are a couple things where they're both green, right? And those are things that you might actually be able to do a bit easier because we all have different incentives, and the best organizations are the ones where people are all working together. They don't feel like different teams with different incentives. But if you're maybe not in that nirvana state yet, maybe you can go for those kind of two greens at once. It might be easier to convince people to do. So I think if we zoom out, I'm trying to give you a point of view here, which is that the building blocks that we have are super exciting. We've got SHAs and images, we've got standard container formats, we've got orchestration with all that data available for us. But we do have more work to do in the details, both individually, like what we can do to secure ourselves, and as a community, like what we can do to secure the ecosystem. So one thing that I talked about recently was, you got to run fast to do Kubernetes security. And that led someone to say, well, yeah, run faster, just run faster than the other person, the bear won't get you. But that's not really satisfying as an answer. I think as a community, we actually need to all work together such that the last person isn't actually getting eaten by the bear. Like, let's all get to the front of that. And by putting all this stuff in declarative specs and adopting these practices and shaping our orgs to match that, I think we're in a great place. So I think that's it. I think I'm getting the high sign. There was supposed to be one slide here about ways to get started. I'll post the slides after, but basically, like, start with the easy stuff. Then you can go for more self-contained changes piece by piece, and then app by app even, because of the ways the defaults work, you can actually use those against your security problems, but just keep going after that. I'll stop for you.
Thank you so much, Connor. Thank you for being a speaker at BSidesSF 2020. Everyone give him a round of applause.